This is Daryl with Cisco Hands-On Training. It is October 16th, 2019. Today I'm going to demonstrate Network Mom ACL Analyzer, which is available in the macOS App Store. This access list analyzer can analyze IPv4 and IPv6 access lists for most Cisco platforms, including iOS, iOS XE, iOS XR, Nexus OS, and the Adaptive Security Appliance. It can find syntax errors in proposed ACLs. Discontiguous wildcard bits are reported as errors. Given a specific TCP or UDP socket, it finds lines in the ACL which permit or deny that traffic. And it has a really cool feature. It can find duplicate ACL lines. It finds lines earlier in the ACL which match a strict superset of a later line. This could be because the later line is unnecessary, or it could be because the earlier line is too permissive. You, as an IT engineer, have to decide the secure way to resolve the duplicate. It is fast. It can find permit or deny matches or duplicates for a 2,000-line ACL in seconds. This is the kind of ACL analysis tool I always wanted during my career, and I'm pleased to have implemented it in Swift. It's available in the macOS App Store from my company, Network Mom LLC, for only $10. And now, on with the demonstration. We have an ACL analysis, permit deny analysis menu item, which pulls up this kind of interface. It's designed so that we put our ingress ACL in the top left window. If we have an egress ACL, we can put that in the top right window. Most companies have an ingress and an egress ACL, and in order for sockets to function, they need to allow traffic in both directions. Of course, the reverse direction traffic, the socket is reversed and may have the TCP established flag added. So let's cut and paste an ACL with several errors in the top left window, and we're going to click Validate the ACL. So let's look at line number 2. Line number 2 has an IP address it matches 3.7.4.18 with wildcard bits 0.0.0.3. Now the 0.0.0.3 makes this match basically a /30. However, the .18 IP address is not on a /30 bit boundary. And my tool has successfully detected that line number 2, the source IP, is not on a net mask or bit boundary. In fact, it's also detected that the destination IP address is also not on a net mask or bit boundary. And it's issued warnings. It's still going to calculate the ACL because this is still a valid ACL line, but it's given us warnings that the IP addresses that it matches may not be what you'd intuitively expect. Let's look at line number 5. Line number 5 has a dangerous error. It has a net mask. However, this is iOS. iOS ACLs are do not care bits. So this line will match every IP address that ends with a 0. So while we may think we're allowing in a specific subnet through our ingress ACL, we're actually allowing in every IP address that ends with a 0. We've marked that, my tool has marked that as an error. It does not let you continue if you have discontiguous do not care bits, because in general, those are the results of human error, and you need to correct them. Let's go ahead and paste our egress ACL in the top right window. Let's go ahead and ignore these errors, which means, of course, that line 5 and line 6 are not included in our calculated ACL. And let's enter in a socket. So socket of source IP of picking a random IP 3.7.4.16. We're not going to pick a source port. The tool will pick a random high source port for us. Destination address 2.2.2.2. Protocol is TCP. We're going to pick a destination port of 80. And we're going to click Validate ACLs and Analyze Socket. So the tool has successfully found that line 2 is the first match, and actually the only match, for this socket in our ingress ACL. In addition, the tool has found that line 1, the permit TCP any established line, matches the reverse of the socket, which, since it's TCP, includes the TCP established flag. With a 10-line ACL, you can do this manually, but most production ACLs are hundreds or thousands of lines long. You need to have a tool which shows whether a socket is already permitted by an ACL. That can prevent you from needing to execute changes to add lines that are unnecessary to your ACL. Let's do an IPv6 NXOS example. So let's clear our windows. Let's grab an IPv6 ingress ACL for Nexus OX. And the most important thing when using the tool is to actually set the device type appropriately. So we're going to set IPv6 NXOS as our device type. We'll go ahead and validate, and we have no errors in our ingress ACL, and it's showing that it's confirming that it's not analyzing anything for the ingress ACL because we've left that blank. Let's go ahead and put in a socket. We're going to put in a source IPv6 address. We're going to set our protocol to UDP. We'll make the source port blank again. We'll put in our destination IPv6 address, and we'll leave the destination port as 80. And we're going to click Validate ACL and Analyze Socket. As you can see, we actually have 3 lines that match our socket. Line 2 matches the permit IPv6 any. Line 3 matches permit IPv6 2001:db8::/32 any, and then line 5 also matches. In a router, the first match is the only one that matters, but for the tool it is useful to have the also matches so you can see every line in your ACL that matches the particular socket. Let's look at, so that's matching permit, and that's permit and deny analysis. Let's look at duplicate analysis. We can pull up an ACL analysis duplicate analysis menu to pull up a new window. Let me get an iOS XR ACL with plenty of duplicates. And again, we need to set our device type appropriately because the syntax for these different Cisco platforms, each of them is a little bit unique. And let's validate the ACL and search for duplicates. First, that was fast, but this is only 10 lines. Now, line 2 matches permit IPv4 any. So every later line is considered a duplicate. That's pretty obvious. But let's scroll down to line 4. It matches all TCP established traffic. The tool successfully identifies line 10 as a duplicate or as a subset of line 4 because line 10 matches a specific set of established traffic. Scrolling down to line 7 is interesting. Here we have permit TCP host, and we've got a source range, and then for the destination port, we have ports less than 10. The tool successfully identifies that line 8 is a strict subset of line 7, so it's a duplicate because the source port equal 10 is in this range. The IP addresses match. The destination port equals 3 is a subset of less than 10. Line 9 is also cool. Here we match this IP address and port combination, and the tool successfully understands that line 10, which is the same combination but with the TCP established flag, is a subset of line 9 and is therefore a duplicate. In a large ACL, it's very helpful to find duplicates. The earlier lines are supersets of the later indented lines. If an earlier line is a superset of a large number of later lines, that may be a warning that the earlier line is too permissive. Let's do one more test. To help with testing, my tool has a utility which generates random ACLs. So let's generate a random IPv4, IPv6 ASA ACL. ASA ACLs are unique because they include both IPv4 and IPv6 lines in the same ACL. And here's our ACL, our randomly generated ACL. It's actually 2,000 lines. You don't want to use a randomly generated ACL in production. This is only for use of this test. So we copy and paste everything and we put it in our 2,000 lines into the tool. We set the device type to be ASA, combined IPv4, IPv6, and we click Validate ACL and search for duplicates. Look how fast that was. We were done in 3 seconds, and that's 2,000 lines. As the number of lines doubles, the amount of time required to find duplicates quadruples. But you can still find duplicates, search for duplicates in a 10,000 line ACL in minutes. Now, ASA ACLs use net mask syntax instead of don't care bit syntax, and my tool obviously handles that case provided you set the device type properly. And here it's found that line 76 is a superset of all of these other lines. And then it found that line 161 was a superset of all these other lines. In random ACLs, because you only have 32 IPv4 bits, you tend to find a lot of duplicate IPv4 lines. Now, you may be concerned about the information security aspects of putting your access lists in a tool. This tool is distributed through the macOS App Store, and it went through app review. It uses Apple's application sandbox feature and is not allowed to make inbound or outbound network connections. So it is impossible for this tool to phone home with any of your data. One side effect of that is that the tool cannot make DNS requests. So ACLs which use fully qualified domain names in their configuration are not supported. So that's the tool, Network Mom ACL Analyzer, available in the macOS App Store from my company, Network Mom LLC. This is the ACL analysis tool I wanted during my career. I'm pleased to have implemented it in Swift and make it available to network engineers everywhere for only $10. One final request. If you like the tool, I would appreciate it if you could tell your friends or give me a positive review in the App Store. If you have an issue with the tool, feel free to email me at feedback@networkmom.net. I've been gradually making this tool better by adding more platforms, and I'd like to make the tool useful for you. Thank you.